So students, last time we have done up to the blockwise classification of periodic table. We had classified the periodic table as S block, P block, D block and F block. Now this time we will be talking about effective nuclear charge. You have already referred the notes and you have also referred the textbook. So our idea is to understand the concept of effective nuclear charge in a proper way. The point is this, कि suppose there is an atom and for that atom, let's say I am talking about atom of magnesium. So magnesium atomic number is 12. So in the nucleus there are 12 protons, there are 12 neutrons, that is the nucleus. In the first shell there are 2 electrons in the S subshell. I am just denoting they are in the S subshell, so I am writing them as S. In the second shell there are 8 electrons, out of that 2 are in the S subshell, remaining 6 are in the P subshell. P subshell, it's like this, right? And in the third shell there are 2 electrons in the S subshell. I am writing it over here like this. Now if you are thinking how much force of attraction the outermost shell electrons will be enjoying from the nucleus. So if you think that the force of attraction is equivalent to the 12 protons, well, that will not be the case. Now what is the reason? The reason is that between the nucleus and this particular electron, if I am talking about this electron, there are some barriers. What are the barriers? The cloud of the electrons, that is in the first shell, this electron cloud which is going on, moving around. It is in the diagram it is static, but they are moving around. Then in the second shell there are 8 electrons, so they are all moving around. So they are also eating away a little bit of force of attraction, and they becoming a barrier which is they are shielding. Also this electron which is there, it is having a force of repulsion with the other electron over here, and this repulsion and this shielding by the inner shell electrons will make sure that the effective nuclear charge is not equivalent to 12, it will be less. So that is the basic idea. What is the effective nuclear charge, which is denoted by Z effective? In your textbook it has been defined as the net nuclear charge actually experienced by an electron is called effective nuclear charge. So if you think of individual electrons, every electron, I would say the effective nuclear charge enjoyed by the first shell electron will be the maximum, because there is no barrier, there is no shielding effect. Only factor which will be working against the enjoyment of overall nuclear charge is that their mutual repulsion. In the second shell there are 2 factors which will be diluting the effective nuclear charge. One is the mutual repulsion between the electrons, another thing is the barrier of the first shell electrons. That is what will happen to the second shell electrons. And third shell electrons will have the least effective nuclear charge, because they are having 2 difficulties. One is the mutual repulsion between the 2 electrons in the same shell, and also the barrier provided by the inner shell electrons. So that is the basic idea about the effective nuclear charge. Is that clear to you, children? Now this effective nuclear charge, there is a method of calculating, and that I have given it in my notes. So I will just go point by point about those how to calculate the effective nuclear charge. So I will go through it. Now when you calculate the effective nuclear charge, you calculate it by a rule which is called a Slater rule. Now and another thing you must understand before I get into the Slater rule, that is the barrier which is given by the inner shell electron will be more effective than the next shell, than the next shell, than the next shell. How I will tell you. For example, if you are looking at the board, now if I put my hand palm over here, so it is becoming a barrier, and camera is the nucleus, let us say. But if it is coming here, the barrier is, I have come closer to the nucleus and the barrier is more. Your vision is becoming lesser. If it is brought here, then your vision has become even lesser, and when it is coming here, your vision of the board is almost not there. So that means this is what is an indication that closer the barrier of the electrons, more effectiveness in the shielding of the outer shell electrons. That is how you will see that as I'm taking this palm away, your vision is becoming more and more clear on the board. So that is one thing you have to remember, that inner shell electrons will create more barrier than the outer shell electrons. Is it clear to you, children? So the rules, when you talk about the rules, is like this. So I'll just go about it. The first and foremost point is write down the electronic configuration of the atom. By the way, the calculation of effective Z effective, calculation of effective nuclear charge, that is Z effective, and it is by Slater rule. The scientist responsible for this is Slater, by Slater rule. So I'm not writing the points because it is given in the notes. So I'll just talk about the first and foremost thing. You have to write the electronic configuration as 1s2, 2s2, 2p6, 3s2, etc. But then when you write it, I'll just tell you. For example, suppose I'm writing the electronic configuration of zinc. So first thing they said, write the electronic configuration. So let us say I'm talking about zinc atomic number 30. So I'll write it as 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, and then 3d10. This is how we write, because this is the order in which electrons have entered. But mind you, this 3d is inside and 4s is outside. That means if I consider this is the nucleus, this is the first shell, this is the second shell, this is the third shell, then the fourth shell. So that way if I write, I have to write it as 1s2, 2s2, 2p6, 3s2, 3p6, then 3d10 I'll write before. Actually it is getting filled afterwards, but I have to write it before because third shell is before fourth shell, and then I write 4s2. So that means that from the nucleus, if the charge that the 4s, when it is experiencing attraction, for that the barrier that is made, even 3d is making a barrier because they are inside. So you have to rewrite the configuration in this manner. That is the first and foremost point. The second point, any electron to the right hand side of the electrons of the interest does not matter. Suppose, what I mean is, suppose I am thinking of the effective nuclear charge of 3d or any of the electrons of 3d, then this 4s will not matter because it is after this. So it is not becoming a barrier, it is not causing the shielding. So suppose I am thinking of the effective nuclear charge falling on the 2p6. In that case, I will not think of all these electrons because they are after that. So that is what is the second point, that any electron to the right hand side of the electron of interest, that is considered electron, does not matter. The third point is all other electrons in the same group as the electron of interest contributes 0.35 charge unit. That means the shielding by suppose I am thinking of the electron of 2p, this 2p. So all the electrons over here, they will cause a shielding of the value of 0.35. But if I am thinking of 4s, then in that case, one electron of 4s, that in that case, this the one electron is of the interest, other electron will be causing a shielding of 0.35. तो जो शेल का you are thinking, वो शेल में the outer shell, उसमें बाकी जो इलेक्ट्रॉन है, they will be causing a shielding of 0.35 unit. If the electron of interest is of S or P, then the electrons with one less value of the principal quantum number shields to the extent of 0.85. What I mean is, that is, suppose I am thinking of 4s का electron, इसका I am thinking of the effective nuclear charge. So in that case, the fourth in that case third shell का जितने भी electrons है, I'm sorry, they will be giving and shielding of each electron will be giving a shielding of 0.85 if it is a 4s. Now if it is a 4p, suppose there was 4p6, तो उसके लिए भी all these will cause 0.85. The rest will cause a screening of 0.35. Is that okay? All the electrons with two less value, that is the fourth, third, second, two less value. Now A sub, they will be giving a shielding of 1 unit, and this also will give a shielding of 1 unit. So I hope you understood that fourth cell ka, if I am considering an electron of the fourth cell, then fourth cell ka baki electron, they will cause shielding of 0.35. Third cell ka, they will be causing shielding of 0.85, and second, first, they will be causing a shielding of 1 unit. Then the next point, which is very important, if the electron of interest is an D or F electron, all electrons of the LHS shields to the extent of 1 unit. Now this is, that was 4p, and then I am thinking of 4d, suppose this is 4d5, and I am thinking of, just it is a hypothetical situation, I am thinking of the shielding of a d orbital electron, okay, Z effective of d orbital electron. In that case, shielding by the rest of them is 0.35, and all of them will be shielding by a unit of 1. And even if it is 4f, then for that also all of them will be causing a shielding of 1 unit. So it is s or p orbital electron in the outermost shell, then the next shell, just next inner shell 0.85, and uske andar ka sab 1. But if it is D or F, then uska 1 shell less, and everybody else will be causing a shielding of 1. I hope you got my point. I repeat once again, if I am thinking of S and P, now in that case this will be 0.35, all it is a fourth shell, so third shell ka sab log, each one will be 0.85, and they will be 1. But if I am thinking of 4D, then this is 0.35, but then this all 1, this also will be 1. If I am thinking of an electron of 4f, then all of the rest will be 0.35, this will be all 1, this will be all 1. So S or P ke liye inner shell, just immediate inner shell will be causing 0.85, and uske bhi inner shell will be causing shielding of 1. But for D and F, immediate inner shell, the onwards everybody will be causing a shielding of 1. So and if the electron of interest in a D or F electron, all electrons to the left hand side shields to the extent of 1 unit. Ye consider karke, then you have to sum the shielding amounts, and that is how you will be calculating the value of what is called a screening constant. So you are this first you have to calculate the screening constant, then you have to calculate the Z effective. So screening constant, so what I told you, 0.1, 2, 3, 4, 5 and 6, all these things that I have discussed, this is related to the calculation of screening constant, or children you can call it a shielding constant, and it is denoted by sigma. Is that okay? So let us take an example so that we can understand how to find out effective nuclear charge. So I think of fluorine. So if I am thinking of fluorine, so fluorine, Z effective for fluorine I have to calculate. So fluorine atomic number 9. So configuration is very simple, 1s2, 2s2, 2p5. So 2 plus 2, 4 plus 5, 9 electrons. Now when I find out the screening constant, so how I do it? Now in this there are total 7 electrons. So one electron I'm thinking of. So if you think of it, this is the nucleus, this is the first shell S, and the second shell S, and then P1, P2, P3, P4, P5. Let's say I want to find out the effective nuclear charge on this particular electron. तो इसका खुद का शेल में और कितने इलेक्ट्रॉन है, एस और पी का है, तो बाकी लोग कितना कंट्रीब्यूट करेगा, 1 2 3 4 5 6, देयर आर 6 मोर, तो ईच वन विल बी 6 इंटू 0.35 प्लस ये हो गया, और देयर आर 2 and they will be 2 into just in the inner 2 into 0.85. So the contribution it will be 2.1 plus 1.7. This will be 3.8. This is the screening constant. Now Z effective is the atomic number minus screening constant. So atomic number is 9 minus 9. Screening constant is 3.8. So the value comes to 5.2. So this is how it is for fluorine. Is it clear to you, children? Now, if we think of the zinc, so for zinc you will calculate it in this way, and then I will go for platinum after that. So suppose I think of zinc, so zinc atomic number 30, so configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d10, but this 3d is before, so therefore that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s बाद में आएगा, 3d10 and then 4s2. So suppose I am thinking of the Z effective for the 4s, this one electron in the fourth cell. So Z effective for 4s electron, any of the electrons. So in that case, first and foremost thing, I have to find out the screening constant, that is sigma. So how I find out screening constant sigma? So this will be, if you see, so एक इलेक्ट्रॉन I am considering, so दूसरा इलेक्ट्रॉन, एक ही इलेक्ट्रॉन उसका साथ में है, so there is another electron, so in the fourth cell, so first, second, third, fourth में there are 2 electrons. So I am thinking of this, so इसका neighbor has only one in the same shell, so therefore it will be 0.35 into 1. Then in the third shell there will be 10 plus 6, 16 plus 2, 18. There are 18 electrons are there, and they will be causing screening effect of 0.85. So 0.85 into 18 plus उसके बाद how many electrons are there? Then inside each one will be contributing, so they are contributing, so here एक is contributing 0.35, here all are contributing 0.85, and rest inside they will be contributing 1. So it will be कितने है, second shell हो, first shell हो, they all 6 plus 2 8 plus 2 10, so this will be 1 into 10. So therefore it will be 0.35 plus 15.30 plus 10, so this comes to 25.65. Now Z effective for that fourth cell S electron, so Z effective will be atomic number Z minus screening constant, so that will be 30 minus 25.65, and this comes to 4.35. Is that clear to you, children? I hope you understood. But suppose I want to find out one electron of the 3d, ये जो 3d है इसका 3d एक इलेक्ट्रॉन का बारे में, there are 10 electrons but there are 3d ऐसा 10 electrons है, 3d like that 10 electrons are there, so I am thinking of only one electron, उसका effective nuclear charge क्या होगा? So if I have to find out that, so in that case how I do it, you just see this. So point is this: for a 3D electron, 3D electron. So how I do it? First I have to find out screening constant, that is sigma. So when I find out screening constant sigma, first and foremost thing, this on the RHS, so this is insignificant. It will not contribute any shielding. So when I think of 3D, so what will happen? So in that case, in 3D there are rest of the 9 are there, so it will be 0.35 into 9 plus कितने इलेक्ट्रॉन है? 8 16 plus 2, rest are 18. So rest, so this will be called, this of the same category, it will be 0.35. But all these, although they are in the same shell, but they are of S and P, so their screening effect is more because they are closer to the nucleus. So in that case, say they all will be contributing to 1. So it will be 1 into, just count it, 6 plus 2, 8 plus 6, 14 plus 2, 16 plus 2, 18. So this will come to 3.15 plus 18, and that means it will be 21.15, and Z effective will be Z effect will be Z minus sigma. So that is 30 minus 21.15, and that comes to 8.85. Now you can see that when it was S electron एकदम outside, उसका effective nuclear charge was 4.35, उसका था 4.35. I've just now we calculated, but inside इसका effective nuclear charge is more, as we expected, 8.85. I hope you got my point. Is that okay? Now the next one that we do is of platinum. Platinum atomic number is 78. So how we'll do? Now let's quickly revise. First thing we have to find out screening constant sigma, and then atomic number minus screening constant will be the Z effective, that is effective nuclear charge. So platinum atomic number is 78. So platinum atomic number 78, so it will be 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, 4s2, 3d10, 3d10, then 4p6, then 5s2, 4d10, then 5p6, 6s2, then 4f14. Just check in your notes if I have given this. And then 5d8. 5d8. This is what is the electronic configuration of platinum. But if I put them in the proper order, so how I will do it? I will do it or I will write it as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, I'm sorry, 3p6, then 3p6, then 3d10, ये पहले आएगा, then 4s2, then 4p6, then 5s, I'm sorry, 4p6, then 4d10, 4d10, then 4f14, then 5s2, उसके बाद आता है 5s2, उसके बाद आता है 5p6, 5p6, उसके बाद आएगा 5d8, and I'm thinking of the effective nuclear charge on this one electron in the 5d. So what I will do, I will do it like this. It is in the 5D. So, 5D 8 and then after that 6s2. Sorry, 5d8 and then 6s2. So, I am thinking of one electron of the 6s. So, ये जो 6s का electron है, तो sigma, one electron I am considering. The other electron will be contributing how much? 0.35. So, 0.35 into 1. And since it is of that, then उसका previous shell में, उसका previous इसमें, it will be 8 and 6, previous cell में 8 and 6, 14 plus 2, 16, 14 plus 2, 16, yes. So, in the previous shell, there are 16 electrons. And so, here 8 will be contributing 0.35. इसमें each one will be contributing 0.85. So, this will be 0.85 into 0.85 into 18. And ये जितने भी है, they all will be contributing 1 inside. And that will be total, if you count, 24 plus 6, 30, 32, 42, 48, 50, 56, 58, 60. So, it will be 1 into 60. So, this will come to 0.35 plus 13.601 plus 60. So, this will come to 73.95. So, Z effective will be equal to Z minus sigma. Z is how much? 78 minus 73.95. So, this will be 4.15. 4.15. Now, if you see, the fellow has got 78 protons inside, but the outermost shell 6s electron is enjoying attraction, effective nuclear charge is only 4.15. So, that is how it goes. Is it okay, children? So, with that, I think we have understood how to do the calculation of effective nuclear charge. Now, quickly, I just remind you the method that we have followed by the Slater rule. The first and foremost, write down the electronic configurations 1s2, 2s2, etc. Any electron to the RHS of the considered electron is insignificant. All of the electrons in the same group as the electron of the interest contributes 0.35. Like here, one is एक का पकड़ है, बाकी सब 0.35. If the electron of interest is of S or P, then all electrons with one less value of the principal quantum number will be 0.85. Is that okay? All the electrons with two less value of the principal quantum number shields to the extent of 1 unit. But then you have to understand this properly. If the electron of interest is D or F electron, all electrons to the LHS shields to an extent of 1 unit. That is, if I had considered 3D, then they would have been 0.35 and all this would have contributed to 1. Sum the shielding amounts and then do the calculation. Is it clear to you what I said? So, with that, we have finished the calculation of effective nuclear charge. The next thing that you have to do is heading number 7, that is periodic trends in properties, and that I will be discussing in my next video lecture. Okay, children, thank you. Thanks a lot. Hope you have understood the concept properly. God bless you.